In this part of our project, we will be dealing with statistical significance, and in particular, we will be doing hypothesis testing. So before we go to the analysis of this hypothesis testing, there are some ideas or concepts we need to learn first so that we would be able to properly understand what's going on in our data. So let's have these things. We will be talking about ANOVA, the Kruskal-Wallis, and Mann-Whitney. So first of all, the decision of using an ANOVA or Kruskal-Wallis test is the distribution of data. So we have to differentiate between the normal distribution and the non-normal distribution. So when it is normal or Gaussian distribution, then we're going to use ANOVA to analyze the data. When it is not normal or non-Gaussian, then we're going to use Kruskal-Wallis to do the distribution. To do the analysis. The major difference between the Mann-Whitney U and the Kruskal-Wallis H is simply that the latter, or the Kruskal-Wallis, is or can accommodate more than two groups, while the former one, it cannot. The ANOVA and t-test is explicitly a test of equality of means of values, while Kruskal-Wallis and Mann-Whitney can be seen technically as a comparison of the mean ranks. So there are actually a lot of resources or sources of information that you can use for you to be able to properly understand more about these different concepts. But if you are a statistician, then you have an advantage on the technical usage of these concepts. Now let's go back to our project. In this case, we have here plotted our hypothesis. So we have the null hypothesis and alternative hypothesis. So these two are very important concepts in data science, machine learning, and even statistics. So our null hypothesis is this: the data is normally distributed, and the alternative hypothesis is the data is not normally distributed. So first of all, we're going to import the scipy.stats, and then let's execute this. So we would know then, we could see the result here. The p-value is 0.0, right? So first we're going to select the object, data type objects. So these are the columns we're going to test. So let's execute this. We have these different columns, categorical columns to be more specific. And here we have identified which of those categorical objects that can be under the Mann-Whitney or ANOVA. If it is more than 2, and if it is just equal or less than 2. Okay, let's execute this so we would know. So for the ANOVA, we have customer, state, coverage, education, employee status, location code, the marital status, the policy type, renew, sales channel, vehicle class, the vehicle size. For the t-test, we have the response and then the gender. So maybe you are wondering why we have separated or categorized these different categorical variables into two, ANOVA and the t-test. It's because, first of all, as we have already discussed, the response can be only yes or a no, so there are only two options. And gender, as far as our data is concerned, we have only two, men or male and female. So definitely for these categorical variables, we're going to use the ANOVA and or the Kruskal-Wallis. And for this one, we will just use the Mann-Whitney. We have here our hypothesis that we are going to test. The null hypothesis is that the distributions of both populations are equal, and the alternative hypothesis is the distribution of both populations are not equal. Let's first have the response. So because there are only two, then we're going to use the Mann-Whitney. So let's first see how they behave using a distribution plot. Let's execute this, and let's see if they have the same distribution. Okay, as you could see, definitely there is no the same distribution, and we're going to separate the yes from the no. So let's execute this one, and of course for each one, we could see the customer lifetime value. In this part, we will name this one yes no, which means the comparison between the yes response for no. It's just something's wrong with this one, so let's make this one yes. This one is no. All right, so let's execute this one again. As what I've said, this one is a combination of yes and no, and so we could see the comparison between them. And so let's execute this one. The p-value here is 0.34, and remember this, that our basis is 0.05. So because our p-value here is higher than 0.05, it means that these two responses, yes and no, don't have the same distribution. Apparently, we could see that in the distribution plot here, right? Now let's go to the Mann-Whitney gender. So again, in this case, we use the Mann-Whitney for the same reason that we have already discussed. So in the same case, we're going to do the plot distribution. I mean the distribution plot. Let's execute this. And so there you are. They actually have somewhat a similar distribution. And so we're going to test that using the Mann-Whitney. Now let's do the separation of responses again. So let's execute this. And then we will do the Mann-Whitney. Let's see if they have. Okay, so the p-value is 0.281, so it fails to reject the null hypothesis that both male and female have the same distribution. Let's go to Kruskal and one-way ANOVA. So we have the test hypothesis here. The null hypothesis is the groups have the same mean ranks, and the alternative hypothesis is the groups do not have the same mean ranks. This time, we are testing the state category. So let's execute this one first. Okay, so as you could see, the distribution apparently is not really the same. So nevertheless, we still have to check by using the tests, the Kruskal and ANOVA. So let's execute this one. And then let's do first the Kruskal-Wallis. And the p-value is 0.13 or 14, just rounding it off. And it fails to reject the null hypothesis. Another test is we're going to use the ANOVA. So the p-value is 0.88, so it still fails to reject the null hypothesis. Okay, now let's go to the coverage. So we have three categories here for the coverage. We have the basic, the extended, and the premium. So let's see how they behave using the distribution plot. Right. So basically, and apparently, they don't have the same distribution. So we will do the same thing. All right, and now let's the Kruskal. So the p-value is really very high, it was 1.79. So apparently this is higher than 0.05, and it fails to reject the null hypothesis. So let's do this, and it's the same. It does not reject the null hypothesis. So this time, let's go to education. And education, we have 1, 2, 3, 4, 5 categories or levels. Then we have the bachelor, the college, high school or below, the master, and the doctor. So let's execute first this one. Okay, so you have in there the distribution plot of each. So apparently they don't have the same distribution, but we need to test too how they behave using the Kruskal-Wallis. So let's execute this one. So the p-value is 0.02. So which is higher or lower? 0.02 or 0.05. So in this case, they have actually similar distribution. And with that, we could say that the null hypothesis is accepted. It's because the p-value is 0.02, which is lower than 0.05. So let's test this one using the ANOVA. So let's just copy this just to make our life easier. And let's paste this one in here. So let's see. Doc. And then we have okay, so we have in there the value is 0.05. So the values here of cross-call result and the one-way result are different from each other. So remember that they have both different functions. And because we are talking here of the ranks among different categories of education, so we may as well have to follow education or the p-value in education using the cross-call result. However, if your way of doing is different from the comparison of mean ranks, then we're going to use the result of ANOVA. Do you want to know more about this channel? Just click these cards. We do have a lot of free data science courses for free like Machine Learning Essentials, Deep Learning Mathematics, and a lot more. Here, you can always learn an upskill for free.